Okay, recording has started. So shall we start now? Yes. The properties of binary relation which we will discussing. You have been given one assignment in the last week that you should go through my videos on the special properties of binary relation. I hope you must have gone through the same. Okay. So what are the properties of binary relation? There are 6 different properties, namely a binary relation is reflexive, it is irreflexive, it is symmetric, asymmetric, anti-symmetric, and last one, transitive. Okay. These are the 6 properties on which we are going to play around uh, related with the relations and functions. Okay. So just a second. Let me close it. Some replies. Sir, please share your screen. Yeah. I was just cross-checking if all are present. Okay. I was aware that screen is not shared, but I was checking how attentive you all are, and I got 60 replies that screen is not visible. That means you are attentive. Okay. Now let us start. So there are 6 properties of binary relation, namely reflexive, irreflexive, symmetric, asymmetric, anti-symmetric, and transitive that we are going to discuss in today's lecture. Have you gone through the video lecture about properties of binary relation? Have you seen the lecture? Whether now screen is visible? Are you able to see the screen? Yes or no? At least any reply if screen is visible. Whether it is visible? I think it is visible. Look, I am able to see, and you should also be able to see. Is it visible? Not visible?
Yes, sir, it's visible.
Let me start now. The properties of binary relation, as I was discussing so far. Give me a second. Let it load. Yeah. So the very first property of binary relation, a binary relation R on set A is said to be reflexive if we are having a pair A comma A present in relation R for every element small a belonging to capital. What is the meaning of this? You would say a binary relation is reflexive if and only if there is a self loop present. There is a pairing of every element from set on which relation R has been defined exists with itself. So you must have pairing of all the elements with their self for becoming a relation as a reflex. Are you ready? So if I take a set A, let us say set A is having elements. I hope this is now visible. Look, set A is having elements 1 comma 2, and I am defining a relation R. Relation R is comprised of elements like 1 comma 1 comma 1 comma So how many relations are possible on A using our formula? What is the formula? To compute number of binary relations possible on a given set. Can you repeat? Am I audible? Hello? Yes. Yes. You have seen that video lecture as well, you're saying, okay, and I'm audible. So my first question is, how many relations are possible on set A? Set A is having two elements, 1 comma 2. We have to find how many relations are possible on B. Can you tell me? How many relations I can define on A? Quick reply. No, no. 4. Yes, Sunny, you are specifying the pairs. I am asking how many relations are possible. So you are saying 4? Whether only we will have 4 relations? I think there will be total 16 relations possible on set A. What is the formula? Formula is number of possible binary relations on a Cartesian product of A with B. Having cardinalities m and n is 2 to the power mn. Here we are going to define a relation on set A cross A. So what is the cardinality of A cross A? 2 to the 4, 2 raised to 4, 16 and not 4. Those who are saying 4, you are wrong. Your answer should be 16. Are you getting my point? Am I clear how it will be 16? At least say yes or no. It will not be 4. Okay, it will be 16. Those who were saying 4. So this is the mistake that you are going to do. Okay, every time in examination. We are not defining a relation on single set. We need a Cartesian product of two sets to define a relation. So number of elements present in first set multiplied by number of elements present in second set, and as it is a binary relation, we are taking it as an exponent of 2. So 2 raised to 4, we will have 60. Now I have defined a relation R on A cross A having two pairs 1 comma 1, 1 comma 2. My question is whether R is reflexive. Whether R is reflexive. What is the definition of reflexive relation? A relation R will be said to be reflexive if every element is related with itself. In short, if you are having element small a present in original set A, there must be a pair A comma A present in R. So is it reflexive? No. Why it is not reflexive? Because I am not observing a pair 2 comma 2 which is present in R. Are you ready? I must have 1 comma 1 as well as 2 comma 2 in order to be a reflexive relation. Let me take other example, okay, for your understanding. So we are discussing about reflexivity. So my set is A equal to 1 comma 2, B is 2 comma 1, R1, R2 equal to R2 is 1 comma 1, 2 comma 2, R3 is, let's say it is 1 1, 2 1, 2 2. So can you tell me out of these R1, R2, R3 which are reflexive? Which are reflexive out of these R1, R2, R3? Whether R1 is reflexive? R1 is reflexive? No, it is not reflexive because I am not observing a pair 1 comma 1. Whether R2 is reflexive? Yes, it is reflexive. Because I am observing pair 1 comma 1 comma 2 comma 2. How about R3? Whether R3 is reflexive? Yeah, R3 is also reflexive. That is the reason why I have taken this example. In case of reflexive binary relation, we are interested in having a pair of element with itself as well as we may have any extra pairs that we are not interested in. We will check out if the self pairs are present. If so, we will treat it as a replace. So some of you may have confusion that this pair is present and how sir you are going to tell this as a reflex? I repeat, I will only check if 1 comma 1 is present and 2 comma 2 is present. If both are present, I will treat that relation as a reflexive, irrespective of any other pairs present in your R. Okay, this is fine. So R3 is, yeah. So what is irreflexive? It will be just the opposite of reflexive. A relation on a set A is called irreflexive if for every element small a belongs to capital A comma A does not belong to R. Okay, you should not have any self loop present in a relation R. If that is the case, we will say it as a irreflexive relation. So out of these, okay, I will be taking again R1, R2, R3. Out of these, which are irreflexive? Out of these R1, R2, R3, which are irreflexive? Am I saying R1? Any other answers? Yes, Vaishnavi, Abhishek, and all are saying R1. R1 is wrong. None of the relations is irreflexive. Okay, what is the definition of irreflexive relation? A relation is said to be irreflexive if for any element, okay, whatsoever that element, I must not have any self loop. I must not have a single a comma a present in relation. Let us cross check. In R1, I am observing that there is a pair 2 comma 2. So how it would be irreflexive? No. In R2, I am having both the pairs. So again, it is not irreflexive. In R3, I am having both the pairs. So again, it is not irreflexive. Okay. If I take R4, let us say R4 is 1 comma 2, 2 comma 1, R5 is 1 comma 2. Now, if you are observing R4 and R5, we observe that there are no self loops present either with 1 or with 2. Hence, I can say R4 is irreflexive as well as R5 is irreflexive. Is it fine? We can say this R4 and R5. Am I clear? Is it fine? Are you waiting? Why this earlier three were not? Let me copy this here. Let me say it as this. Okay. So in this case, R1 is not irreflexive. So is the case for here also. So is the case for here also. How about this? Yes, this is irreflexive. Further to this, the R5 is also irreflexive. Is it fine? Okay. So let us proceed. So how can I represent a reflexive relation using a diagram? How can I represent a reflexive relation using matrix? So if I want to represent the binary relation R as a matrix, I would see if all the diagonal elements are 1. Suppose there is a relation defined on set A. So that set is 1, 2, 1, 2. So I have to check if all the diagonal elements are having entry 1. If this entry 1 is present for diagonals, I would be clear that the given relation is reflexive. Are you getting? We are not at all interested in what is present here and what is present here. You could have 0 or 1, but if all my diagonal elements are 1, obviously my relation will be reflexive. What will be the diagram for reflexive relation? You have to check if all the nodes are pointing towards themselves. If the self loop is present for each and every node. So I would have 1. Here, let us say I am having 2. And if I am having the self loops present for each and every node, I will say that it is a reflexive relation. Good. Remember that we are not interested in middle pairs for a reflexive relation. And how to identify a given relation is irreflexive? All the diagonal elements must be zero. If that is the case, a relation will be irreflexive. There should not be any self loop present in the diagram. Again, that will be irreflexive relation. Am I clear? Am I clear? Yeah. Fine. Thank you. I do have one question. Many times this question has been asked in the GATE examination. Those who are preparing for GATE. Okay. How many reflexive binary relations are possible on a set A having cardinality value n, small n? If cardinality value of this is a small n, we know that the total number of binary relations possible on this will be 2 to the power. I am talking about total number of binary relations. The total number of binary relations will be 2 to the power n square. But out of these 2 to the power n square, how many will be reflexive? That is my question. I hope it is making a sense what I am asking you. Okay. Some of you may think that this is a number of reflexive relation. No, I am talking that this is total number of binary relations possible. 2 to the power n square. Out of these, how many will be reflexive? That is my question. No, no, n is wrong. Anuraj, n is wrong. Think of it. Total number of relations which are reflexive. How many are reflexive? Okay. Yes, any idea? They will give you, okay, if the cardinality of set A is 5, how many binary relations which are reflexive are possible on set A? Direct question in GATE exam. They will give you 4 options and you have to select it. If you know this formula, it will be quite easy. And if the formula is not known, it will be harder to predict. That is for sure. Okay. You can take this as an example of case study wherein we were having a number of elements in set A. How many? A is having how many elements? 1, comma 2. I already told you the number of binary relations possible on this A will be 2 to the power 4. That comes out to be 16. Out of this 16, how many can be reflexive? That is the question. Be fast, be fast. We have to cover up all the properties in today's session only. Be fast. If not knowing, okay, you can tell me. Sir, we are not aware of. So, number of relations which are reflexive will be 2 raised to n into n minus 1. So these many binary relations which are reflexive will be possible. You can watch. For this example, we will have at max 4 reflexive relations possible. Okay. Total 4 reflexive relations are possible on set A having 2 elements, 1 comma. You can cross check and later on let me know and take it down somewhere. Okay, 2 to the power n into n minus 1. If you want number of irreflexive relations, you have to subtract this quantity from 2 raised to n square. You will get your answer, whatever it is, for irreflexive. I will not tell about irreflexive. That will be your job to compute for irreflexive. Okay. Let us proceed. The third property of binary relation, what it is. A relation R on set A is called symmetric if we are having a pair A comma B in the relation R, we would observe a pair B comma A present in relation R. Ready? For all pairs A comma B belonging to A. I mean to say, if we are taking a general example, there exists a path from Baramati to Pune. Whether the reverse will be true, Whether there will be a path from Pune to Baramati? Absolutely yes. If I am saying that there exists a road from one location over the other, we are going to have it in reverse. So that kind of relationship is known as symmetric relationship. Right? Example, let me take example of symmetric. Let us say again, we are defining our relation R on set A only. Let me So let us say R, S, T, these are the three relations, and for which we are interested in checking out if something happens to be, it is not happening like this. You have to tell me out of these R, S, T, which are symmetric. What do you mean by symmetric? If we are having pair A comma B in the relation R, I must have a pair B comma A in relation R. That is symmetric. R and T. Yes. Can I say R is symmetric? We will put A and B. Okay. A is 1, B is 1. What is reverse? B is 1, A is 1. So 1 comma 1, 1 comma 1. Yes. Fine. 1, 2, 2, 1. A is 1, B is 2. A is 2, B is 1. So this is symmetric. Okay. Okay. Whether S is symmetric? No. Why? Because I am observing a pair 1 comma 2, but the reverse of 1 comma 2, that's 2 comma 1 is absent in S. So it is not symmetric. See, I am saying not symmetric. I am not written asymmetric. That is something different. I am saying not symmetric. Okay. Whether T, whether T is not symmetric, it is symmetric. T. You could observe 2 1 is present, 1 2 we are having, 2 2 is present, 2 2 in reverse is also present. What could be general example of this? General example of this kind of symmetric relationship? Being a friend of. So if you are saying X is a friend of Y, you could say Y is a friend of X. So being a friend of is a type of symmetric binary relation. Am I clear? Should we proceed? Whether it is clear? Yes, fine. Being a friend of. Okay. How a diagram will be represented for this symmetric relation? No? So if I am having a node A, if I am having a node B, I am talking about diagram. So let us say this is node B. If I am having this OCD, I must have in the reverse arrow. You must have both the arrows. This is the shortcut to check symmetricity. So you can draw a diagram and check out whether every outgoing edge is also incoming using the same pair of nodes which are connected. You may have self loops, but that is not compulsory for symmetry. You can or you can skip as out. Further to this, first of all, we will go for this. Okay, now, I will not take the help of these slides because those will confuse you. Before going for the symmetry, asymmetry, I am having a question. How many binary relations? Number of binary relations which are symmetric on set A. How many? Again, the famous question. This is what I am not waiting for you. You can watch it. It is 2 raised to n into n plus 1 upon 2. You can watch it. Okay. So, in general, you are going to have 2 to the power n into n plus 1 upon 2. Number of binary relations which will always be symmetric. In symmetric, we are considering reflexive relations as well. But along with reflexive, you could have some addition of other pairs as well. Fine. Okay. Moving further, what do you mean by asymmetric binary relation? So what is asymmetry? So how to define asymmetry? Whenever we are having, whenever A relationship with B, then A not in relationship with B is not in relationship with, I mean to say that is if A comma B belongs to R, then B comma A does not belong to. It is like something saying if there is a path from source to destination, you cannot come again. It's a one way. Okay, we can go from one location over the other, but if we try to use the same road for coming back, the entry is not allowed. That is asymmetry. Remember that in asymmetric, you will not have any self loops as well, because self loops are indications of symmetry. So you are not going to have any self loops as well. So I want example from your side. Again, let us say A is 1 comma 2 only. So can you tell me any example of a relation which will be asymmetric? Can you tell? Yes. A relation which can be said to be asymmetric. Any idea? Yeah, yeah. Fine, fine, fine. One comma two. Very nice. Somebody may say 2 comma 1. Only one path exists. You will not have self loops as well. Remember. So if I am writing a relation like this, 1 comma 2, 2 comma 2. Can you tell me what is the type of this binary relation T? What is the type of this binary relation T? 1 comma 2, 2 comma 2. Viraj, that is the reason why I have taken this example. Okay. What is the definition of asymmetry? Whenever A is in relationship with B, there should not be any B in relationship with A. You must not have self loops as well. Self loops are strictly avoided. So how you are going to have 2 comma 2? I am asking about what type of relation T is. So T is neither symmetric nor asymmetric. Are you getting? T is neither symmetric nor asymmetric. Why it is not symmetric? Because for 1, 2 I am not having 2 comma. Why it is not asymmetric? Because it is having self loop 2 comma 2, which should not be present as per the definition of asymmetry. Are you ready? Should we proceed? Yes, fine. Thank you. So, what could be the relation of this? Being a father of, being a brother of, these are the asymmetric relations. You could say, okay, X is a father of Y. You cannot say it in reverse. Y cannot be a father of X. In the similar manner, if I am saying X is a brother of Y, Y could be sister of X as well. So we cannot firmly say it as that particular relation is symmetric. So these are the examples of asymmetry. And again, you cannot say X is a father of X. Can you say? So no. For being a father of, you must have at least 2 entities involved. So there is no self loop present as well here. While a person can be friend of himself or herself, so I can have here, in case of symmetric, being a friend. But that is not the case of being a father of or being a brother. Like, oh, fine. Any example from mathematics? So, example from mathematics, I will say less than relation on set of natural numbers is asymmetric. What will be the elements of relation R, which is defined like this: less than on natural numbers n. What is it? It says that it is a comma b such that a less than b comma and a comma b belongs to n. That is the meaning of this whatever I have written. So R will have elements like 1 comma 2, you could have 1 comma 3, you could have 2 comma 3, and so on. Are you getting anywhere self loops? No, you cannot have any pairs in reverse as well. So this will be a good example of asymmetric relation. Moving further, what to do if I'm interested in self loops? So anti-symmetric, the other kind category of binary relation property, anti-symmetric. I'm saying here self loops are allowed. So what is the definition? Now be careful. Look. R is anti-symmetric if whenever there are two cases. Anti-symmetric if case one. Are you getting what is the difference between asymmetric and anti-symmetric? It is very crucial. Okay, in asymmetric, we were not allowing any self loops. No self loops were allowed. Whenever A is in relationship with B, then you cannot have reverse. What is anti-symmetric? R is said to be anti-symmetric. There are two cases. If we are observing a pair A comma B as well as B comma A present in relation R, then A must be equal to B. This is the definition of self loops. You can have self loops in anti-symmetric relation, but whenever A is not equal to B, then I can have either A comma B present in R or B comma A present in R, but not both. I can have either. That is the anti-symmetric relation. So can you tell me example of anti-symmetric relation? Be quick. Can you tell? 4 is the square of 2. Yeah. Abhishek, yeah. That is also correct for asymmetric. 4 is square of 2 cannot be square of 4. We were talking about asymmetric. Okay. Now I am asking you, can you tell me the example of anti-symmetric binary relation? Yes, it could be 2 comma 2. Anurag, yes. Yes. Let us have some general so that you will understand what I am trying to focus. 1 comma 2. So you can observe here relation R, whether it is anti-symmetric. Yes, I can have self loops if I am observing that A and B are common. Okay, A equal to B, 2 comma 2. Yes, it is absolutely fine. How about this S 1 comma 2 comma 1 comma 1? It is again anti-symmetric, but it will not be asymmetric. This is the second case, case B. If A is not equal to B, I can have either 1 comma 2 or 2 comma 1, but not B. And this is the case for self. Yes, it is anti-symmetric. T 2 comma 1 2 comma 2. How about this? 2 comma 1 2 comma 2. How about this? Yes, it is again anti-symmetric because it is used for comparison of the product strengths and how come this is anti-symmetric or the similar product. Okay, so if you are getting this certain product there, you should compare that with it is again having 2 comma 1, 2 comma 2. But 1 comma 2 is not present, hence I can say it is anti-symmetric as well. From number theory, number theory, less than equal to relation on set of natural numbers n will be a good example of anti-symmetric relation. Am I clear? So you can have self groups, but you cannot have both the pairs present in case A and B are non-equal. Yeah, yeah. Somebody has given the example. 1, 2, 1, 1, 2, 2. Yes, yes, yes. That is also fine. Yes, you can. Very good. RSTU. What she has given, she is saying, I could have both the self groups. Yes, it is fine. But you can have either or. You will not have both. If I put here 2 comma 1, then that relation will not be anti-symmetric anymore. Okay. Now moving out towards the last property of binary relation, which is a transitive. A binary relation is said to be transitive if. Is there anything on slides? Let's check out. So whatever I discussed so far is written here. You should not go with this. Sir. So I think I have already discussed. A relation R on set A is called transitive if whenever we are having two pairs, A comma B belongs to R and B comma C belongs to R, then we will have third pair A comma C also present in the relation. If these are the two pairs A, B, B, C present, you will have third pair A comma C present in R. So let me take an example quickly. That follows the principle of agile software development and testing. That will be detailed in the subsequent lectures, right? So for today, there is another part that we have to cover is the types of. You have to tell me, okay? Check. If less than relation is transitive. Second, check if less than equal to relation is transitive. Again, you would ask me where this relation on n, and again this relation also on. Out of these, which one will be transitive? Can you tell? Yes. Yes. Can you tell? First one is transitive. That you are saying wrong. I will say it is wrong. Let me check out whether less than is transitive. Let us check out R1. I am writing for first. 1, 2, 1, 3. Okay. Now you can see the diagram very clearly. Okay. 1, 4. The terms of the refer to the set of fine, fine. This one is transitive. I thought of something else. Yeah, Abhishek, you are correct. If you could observe pair 1 comma 2, 2 comma 3, this is A comma B, B comma C. What is the new pair form? It is 1 comma 3, which is A comma C. So absolutely. In this similar manner, if I am having a pair 1 comma 4, 4 comma 5, I could have a pair 1 comma 5, and that will also satisfy this less than relation. So it is transitive, right? In the similar manner, you could have less than equal to relation is also transitive. You can cross check both of the relations. Okay, not only first. You will have both transitive. You can cross check. What is R2? In R2 I am having less than equal to. So I will have self loops as well. 1 1 1 2 2 2. I am taking just an example. You could have lot many pairs present in the actual relation. So 3 5 and so on. So 1 1 1 2. I am having new pair 1 2 1 2 2 2. I am having pair 1 comma 2 2 2 3 2 3 2 3 3 5. I will have certainly 2 comma 5 present somewhere down the line. Okay. So both of the relations are transitive. What is the definition? Whenever A comma B is present in R and B comma C is present in R, we must have a pair A comma C present in R. You get it? Is it fine? Should we proceed? Okay, I think somebody's mic is on. Pratiksha, okay, why you have turned on? Yeah. Now, can you tell me? Let us say example number 2 for this transitive only. Let R is A comma B such that A plus B is odd and A comma B belongs to natural number. Can you tell me what type of relation R is? Is it transitive? Is it reflexive? Is it symmetric, asymmetric, or anything? I hope you have understood what I am talking about. So whether this relation R is transitive. Somebody has said yes. Whether this is transitive? Is it transitive, Mrudul? You are saying it is transitive. I think this is not transitive. Let us cross check. R. What is R? A comma B such that A plus B is odd. So we are going to put 1 2. We can put. Then can I put 1 1? No. Can I put 2 1? Yes, it will be fine. Can I put 1 4? Yes. Can I put 4 1? Yes. Can I put 3 4? Yes. Can I put 4 3? Yes. A plus B should be odd. So 1 plus 2, 3 is odd. 2 plus 1, 3 is odd. 1 4, 4 plus 1, 5 is odd, and so on. You could have any. Okay. A relation R is said to be transitive if whenever I am having a pair A comma B and B comma C present in R, I must be able to have pair A comma C present in the same relation R. So let us treat this one as A, 2 as B, 2 is B, 1 is C. So what is the new pair form? 1 1. Can we have 1 comma 1 any time present in relation R? No, because 1 plus 1 is 2, which is not odd. So it fails. It is not transitive. Are you getting why it is not transitive with them? Yes. It is not transitive. No? What type of relation this is? Can you tell me what type of relation this is? Can you tell me the type of symmetric? Is it symmetric? Yeah. Correct. It's so symmetric. Very nice. It is symmetric. What will be the transitive diagram? Diagraph of transitive binary relation. The diagram for transitive binary relation will look like something this A, B, C. So if I do have pair from A to B, this one. If I do have pair A to C, sorry B to C, this one, then I should have a pair from A to C. Okay, be careful about the directions. A to B, B to C. B is acting as an interior vertex. Because of B, we are able to reach C via E. Well, so consider this A as. I used to take this example several times because this is very easy and applicable. This appeals your mind for remembering. Let us say A is Baramati, B is Murga, and C is Pune. So if I am able to reach Pune via Morgaon is the intermediate station. Can I have a path from Baramati to Pune? Yes. Earlier, we used to have buses from Baramati to Pune via Morgaon. Buses were stopping at Morgaon. Okay. Now we are having non-stop buses which are going from Baramati to Pune directly. This is because of transitivity. Relation is said to be transitive if we are having A comma B, B comma C, as well as A comma C present in relation R. Is it fine? Is it fine? Okay. In the meantime, till I take your attendance, I will give you one example that you will be working on. Okay. So, example number 3. Okay, what is it? A equal to 1, 2, 3, 4. A equal to 1, 2, 3, 4. R1 equal to 1 comma 3. 2 comma 3. 2 comma 1. R2 equal to soon I will be posting the assignments related with the first and second unit. 1 1 how to complete within a certain time. 2 1. So I will also give R3 equal to so that we would be also capable to 3 4 complete all these. I hope you have understood all the properties. Okay, I will have quick revision as well in tomorrow's session because this requires practice. Otherwise, there are not many loopholes for misunderstanding, okay, about the properties of binary. You have to tell me which are the properties that are being satisfied by R1, R2, R3. So, question is what? Which properties? Following relations satisfy. Okay. So take a snapshot because I am now going to take your attendance. Okay. After your attendance, you will be telling me this. Have you taken? I hope you are taken. Okay. So work on it. Meantime, you will have your attendance. Okay. Fine. What it is smart school MIS. Just give me a second, it is loading. Okay, do not leave on the meeting. Yeah, VT attendance. Yeah. You have been given a task, okay. Do not wait for only attendance. Complete that task as well. And once you finish, you can go. Okay, I used to receive a lot of queries that why I am starting from the first. So for today's lecture, I will start the attendance from last. Walke Onkar. Okay, first of all, I will mark all present and thereafter I will ask you from last to first. So there are total 81. Yeah. Onkar Walke. Onkar Walke present. Okay. Onkar, if you have taken the snapshot, you can leave. We will discuss this example in tomorrow's class. Okay. Lokhande Onkar, Totevar Baba. Lokhande. Okay. Okay, you can leave. Those who have given attendance. Tor Sakshi, Swami Siddesh, Sorte Aishwarya. Tor Sakshi, Swami Siddesh. Sorte Aishwarya. Shinde Sejal, Shevle, Omkar, Shelke, Ankita. Ankita Shelke is present. Okay. Shinde Sejal. Okay. Okay. Shevle Omkar, Shelar Prasad, Tejal Sindh is present. Okay. Prasad Shelar is also present. Okay, fine. Uh, Shaha Punika, Sarkale, Rameshwari, Sarfaraj Ali. Punika is present. Okay. Sarfaraj Ali. No. साळुंके प्रणव, साबळे निशा, राऊत विराज. रामेश्वरी सरकाळे, विराज राऊत is present. Okay. साळुंके प्रणव, साबळे निशा, निशा साबळे. राठोड परमेश्वर, पवार सिद्धिराज. सिद्धराज पवार is present. Okay. पाटील शिवशरण, पाटील शैजल, परकाळे यश. शिवशरण पाटील is present. शैजल पाटील. Okay. परकाळे यश, पानसरे श्रेयस, निसाद रवी, निमखेडे मनीष. परकाळे यश is present. Okay. पानसरे श्रेयस, निसाद रवी, निकम शुभम, निमखेडे मनीष आहेत का? ओके, फाइन. निगडे अनुराज, नय्यर बलराम, नांगरे आकांक्षा. निगडे अनुराज, आकांक्षा नांगरे. ओके, फाइन. नलवडे ज्ञानेश्वरी, समीना. ओके, फाइन. मृदुल प्रथमेश, ओंकार मोहिते, माटे प्रणव, मास्कर आदित्य. Aditya Maskar is also present. Okay, fine. Who else? Masal Prajakta, Manikari Shubham, Mane Mansi. Prajakta Masal is present. Okay. Mansi Mane is also present. Manekari Shubham. Mate Pranav. Pranav Mate. Have I seen Pranav Mate anywhere? I think he is not present here. Pranav Mate is absent. Okay. So let me mark Pranav Mate as absent. Okay. To next. Mahamuni Pranav, Lambate Abhishek, Kulkarni Pranali. Pranali Kulkarni Lambate Abhishek is present. Pranav Mahamuni is also present. Fine. Pottur Ashish, Kharat Sejal, Amkar Abhishek. Vaibhav Gaikwad, I know you are present, okay, but you have to be there till your attendance is over. Khalate Rutuja, Khalate Rucha, Kate Kimaya. Rucha Khalate present, okay. Rutuja Khalate present, and Kimaya Kate is also present. Fine. Joshi Kakade Atharva, Kandgule Mahesh, Kankariya Yash. Atharva Kakade present. Yash Kankariya. Fine. जोशी प्राची, जोशी अथर्व, जामगाळ नेहा, जाटिया पल्लवी. ओके 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 ओके, फाइन फाइन फाइन. वैभव, नो प्रॉब्लम. जाकिया पठाण, जाटिया पल्लवी. यस. नेहा जामगाळ, अथर्व जोशी. नेहा जामगाळ. हिंगे कार्तिकी, हिंगाने साक्षी. साक्षी हिंगाने आहे. गोयकर शुभांगी, गायकवाड वैभव, गायकवाड पृथ्वीराज. 21 present. Okay. 22 is also present. Farande Swapnil, Farande Pratiksha. Swapnil and Pratiksha, whether you are present? I am not seeing. Okay. Fine. धोत्रे श्री विनायक, देवकाते वैष्णवी, चव्हाण रोहन. रोहन चव्हाण present. Okay. देवकाते वैष्णवी, I think I have seen her somewhere. Okay. बुधावले सिद्धी, बोलशेट्टे श्रद्धा. Okay. बुधावले सिद्धी, भोसले साहिल, भोसले रेणुका, भोसले अनुराग. Okay. Okay, problem. No problem. Fine. Anurag Bhosle is also present. Okay, fine. Bhor Abhishek, Bhoite Ruturaj, Bhoi Sani, Barate Ashish, Bagal Swapnil, Babre Akshada, Amin Abi, Akanksha, Aghav Aditya, Abha Singh, Aghav Aditya, Aghav Aditya, Aghav Aditya. No, fine. I have marked rest of you attendance. No problem. So we are having total 56, and that I observed. Okay, fine. You can leave the meeting. Thank you.